java.lang classes. So in this presentation, we are going to look into few java.lang classes. So these are the classes that are from java.lang package. Java.lang package is the most basic package, core package, I should say. And so these are fundamental classes that you should be familiar with. So let's start with a string class. So of course we have seen string class, usage of string class already many times. Okay, so this not this should be a little bit easier for you to digest. So string class represents combination of character literals, and using Java, strings can be represented using array of characters or string class, and usually we are using string class. String has a bunch of constructors. So examples, so you can create the empty string like this. You can have a character array like this, and then you can create a string from character array. And you can create a byte array, and then you can create a string from byte array. And you can create the character array, and then you specify the index. So this is second byte, and then this is a fourth byte. So you're actually starting from second byte to fourth byte. And you can create the brand new string from another string, and you can obviously assign this string to another string. So you can just print it out. So this basically shows a set of methods that belong to string class. In fact, there are a lot of the methods. So we have seen examples, we have seen examples of char at. We'd like to see the character. We'd like to get the character on that particular index. And we haven't used the compare to. Basically compares the string with a specified parameter, meaning with another string, and returns a negative value if the string comes lexicographically. I mean, you know, all these characters as the numbers, right? They have a corresponding hexadecimal number, and it will compare the hexadecimal numbers of this string. And compared to ignore case, this is something that we have seen before, and equals ignore case and get characters from beginning and end. So you can also call length method to get the length of the string. You can replace you can replace a string. You can get the substring. You can convert the string into char array, character array. You can trim the string. So it will trim leading and trailing white spaces, and you can also get the value of. So basically, it takes a simple data type such as a boolean, integer, and character, and it takes an object as a parameter and returns a string equivalent of the specified parameter. All right, so I'm actually speeding up a little bit because these are some of the easy concepts for you to digest. So char at example compared to. So here we are using a variable, and here we are using the string literal, right? And again, we are using compared to ignore case, equals, and equals ignore case. Yeah, I should actually remove this because this seems like a duplication. And it's converting to char array, and then getting a characters from the starting point and ending point and the length and things like that. Yeah, I have to take a look at the actual documentation to see exact what these parameters mean. The length, replace, and substring. This is trimming it, so it will trim the leading and the trailing spaces. Okay, so that is a string class, just to give you a sense of the methods that are available. StringBuffer Class. So StringBuffer Class is designed so that, so let me actually talk about the usage of string objects. So string object is a final. Let me actually show you. If you actually take a look at the, I'm going to just say string x. And if I take a look at the Java documentation of string class, so this is the so string class is what is called the final. We haven't talked about the concept of final yet, but any class that is a final, that means you cannot, yeah, so let me just explain final here. There's documentation, yeah. So what that means is that you cannot actually extend the string class, and you cannot really, and also string class cannot be mutated. So once created, it can no longer be modified. So it's a final class. The length and content of the string object cannot be changed. Okay. So, when you are actually changing, so, for example, if you do something like this, so string x, so here, so, x is initially sang like this, okay? And now, if you say x is sang plus Shin like this, what happens internally is that it's actually recreating the string object. So here, string object is final, so it cannot be modified. So basically, whenever you are changing it, it's actually recreating string object. So usage of string object for string manipulation, meaning changing, appending, inserting, that is very expensive operation. So that's the reason string buffer was designed. A string buffer works like a string object, but it's mutable and can be modified. Okay, so unlike string object, it can be mutable and modified. And length and content may be changed through some method calls. So so whenever you need to modify or do some manipulation of your string, you want to use a string buffer class for performance reasons. So that is a string buffer. So it does have a capacity. You can set the capacity, and you can append it. It does have char at, just like a string, and get characters and delete insert. So these are the methods that are available for string buffer class for manipulation of your string. Okay, and this works a lot faster than string class object. Because in string object, again, every time you make a change, it has to recreate, destroy the old one and create a new one. Okay, so string buffer, so you can actually see the initial capacity of string buffer, and then you can append it, and you can actually find out the character at the third index, just like in string class method. And you can also change it to convert it into char array, okay? And you can also insert and delete on particular locations, okay? And you can also replace segment of your string. All right, so that is string and string buffer class. So let's take a look at the exercise 0. So when you run the application string constructors, you are basically creating a different string object using different constructors. So we are using the no-R constructor, right? Okay, and then so these are the same thing we see in the presentation. So I'm going to just move forward, and you just create these string objects, and we just display, and the result is going to be like this. Okay, so there's no complication. And string class methods. So if you go to string demo and then if you run it, okay, so return the char value at the specified index. So that's char at method. And this is creating a char array, okay, from a string object, okay. And this is getting chars. So this one, this is the third. Oh, okay, so this is basically, which one is that? So we create the char array, and then oh, I see. So basically, you provide the char array, and you're basically getting the characters from the string array, and then you're basically inserting into char array. Okay. So this is the index. It's starting from 0 to second, and this is from the third. Third in the array. Okay, I believe that's correct. And then you get the length of the string, and then you replace it. Okay. And the substring, you get the substring, and again, this is trimming it. Okay. And string representation of Boolean expression. So basically, when this is a Boolean expression, right? And if you want to get the string value of it, okay, then it will, it will say true and false. Okay. Yeah. So false or true. Okay. And last one is, display the name. And object comparison. So basically here we created two string, and this is something we have done yesterday as well. So whenever you're creating a string object using new keyword, they are in fact different objects even though they contain the same string values, right? So this two equal signs is basically comparing whether they are the same object instance, and they are not, so it returns false. Okay. But if you're using literal, that is a single object instance that is being shared. Okay, so this one should return true. Okay, so in order to see whether they contain the same values or not, we know that we have to use the equals method of the string class. Okay, so that should return the true on both cases. Yeah, again, I should actually move this guy because that's the same thing as this. Oh, yeah, so this one is a capital. This one is the small. Yeah, so this one should return, let's say, this one should return true, and this one should return false. Okay, because this is lowercase. Okay, but if you ignore case, then it should return true. So that's what we should see. So yeah, true, false, and true. Okay. Lexicographical comparison, basically just comparing, the lexicographical, numbers. Okay, so nothing really important, unless you are playing around with the, the characters. This is now string buffer. Okay, so string buffer, and we are seeing the capacity is 24, and then we can append it. We can do try it, and yeah. So these are all the things that we have seen in the presentation, right? So I'm gonna give you guys 10 minutes to try exercise 0. Wrapper classes. So we have actually covered wrapper classes a couple of times already. Okay. So wrapper classes, some facts. Only objects can access methods in object class, and primitive data types are not objects, which means primitive types cannot have methods of object class. As I said before, I think on Monday, every Java class is a child class of object class. Okay. So in fact, if you take a look at the object class, so let's actually take a look at the object class. So I am going to go, I can just choose anything, and they should be, I'll choose a string. Okay. And if you see the Java documentation of it, and you can see class hierarchy here, and the string is the child class of object. Okay, so if you take a look at the object class, it does have a lot of methods. So which means any Java objects can use this method. And that is in fact what is called, let's see, I want to actually, toString. Okay, toString. Every Java object has a toString method. That's the reason I can actually have any object. I can have any object, and then I can actually do sysout and that object. So this is a name object. Oh yeah, this is a string, so this is not a big deal. So I'm gonna just choose an integer x, and 23 like this, and then I can print this out. The x equal and x like this, because integer class is a child class of object class. So again, if you take a look at the Java documentation of integer, you can see integer is child class of number class. Number class is a child class of object. Okay, so again, you can use toString method of object class. Okay, because as we have seen, every object should have a toString. So whenever you're actually printing things out internally, it will convert this object. It will actually call toString method of this object. Okay, and the result of it will be displayed. Okay, all right. So that is That is the advantage of using the object class. Okay. Now, why wrapper classes? So the wrapper classes are needed because, again, object representation need object representation of primitive type variables to use or take advantage of the properties and methods of this object class. Okay, so we can take advantage of all the methods that come with the object. If you're using primitive, then primitive cannot have these kind of methods of object class. Another reason is collection can take only object as its element. No primitive type can be added to the collection. Okay, so we're going to actually talk about why that is a case when you cover collection later on. The reason is, in a collection, we need to find out whether that element, the location is empty or not. Okay, but if primitive type value is allowed to be an element of collection, there is no way that you can find out whether that element, that location is filled or not. That 0 is a valid value, right? So by making a requirement that every element in a collection object is an object, we can check whether that location is filled or not by checking whether it is a null. That is in fact what is called a null. Okay, so that's another reason. So because of these two reasons, the wrapper classes are available for the corresponding primitive types. Okay, and again, the primitive types are designed to provide higher performance. So if you're writing a lot of computation related application, then usage of primitive will provide much better performance than usage of wrapper classes. Okay, so every primitive should have a corresponding wrapper class, and these are genuine Java class. Okay, so Boolean, integer, long, and double, and these are primitives. Okay, so wrapper classes and Boolean examples. So this is a way you can create the Boolean object just like any other object, right? You say new and Boolean, and then you provide a single argument. So we can just display the values of those Boolean values. And we can actually check the equals of Boolean. Now, we haven't talked about the concept of overriding yet. Okay, so in Java, different class will have a different semantical behavior for the same method. Okay, so this equals method for Boolean might be different from string classes equals. In string classes equals method is basically comparing the values of those string objects are in fact the same thing, right? In the case of Boolean, it will just compare whether Boolean, whether they are in fact true, or false and false. Okay, all right, yeah, object to primitive. So this is actually converting Boolean object to primitive. Okay, so you can actually convert from a wrapper class object to primitive and vice versa. All right, so let's take a look at exercise 1, wrapper class. Okay, so wrapper examples. So here we are creating a Boolean, okay, object, and then we are creating Boolean object using another Boolean object as initial value. That's perfectly fine. Okay, and here we are creating the integer object, providing int primitive value. Okay, the same thing with the long. Okay, so these are all allowed. Okay, and double same thing. And now, when you actually do this, so let me actually show you this application. This is wrapper example class. So when you open this project, you actually see something like the warnings here. So it's not a warning, but it's just information. Some of it could be warning. You see this unnecessary unboxing, okay? What this means is that, so this is a case that we are converting Boolean object to Boolean primitive. Okay, so let's actually take an integer that's a bit more, straightforward. So here, we are converting the primitive type value into integer wrapper object, right? And it says unnecessary boxing to integer. Okay, what this means is that from Java SE5, this conversion can be done automatically. Okay, so basically what you can do is integer and x, and you can just give the 5 or int primitive like this. Okay, and so you can just assign the primitive value to integer object like this, and internally, oh wait a minute, what this say, may split, yeah, okay, don't worry about it. So the internally it will convert this primitive value to integer object. So from Java SE5, this is actually supported. Okay, yeah, so this is different error. Okay, so just to make it more, you can do it like this. Okay. Yeah, so yeah, it's actually giving me a different kind of suggestions, but the key point is that int primit, oops. Yeah, this is perfectly okay syntax in from Java SE5 because internally, whenever you are assigning primitive value to integer, it will do automatic, the conversion. Okay, and it's basically doing this for you. And this is called the boxing and unboxing. And we're gonna actually talk. Yeah, now it's actually gone. So it's going to, Yeah, we're gonna actually cover this one later on in Java SE5 if you have time actually. Okay, so that's the message. Same thing over here. Okay, so here we can the Boolean object. Yeah, so same thing. You can also have int value into y, and then you can create the suppose I have an int object. Int object. I can do like this. So I can actually assign integer object to primitive value like this. Again, internally it will do the conversion for you. Okay, so that's basically the message I was talking about in the documentation. So that is what I showed you here. Okay. And 1.2 is various data types. So here, yeah, so here you're basically dealing with char array, integer data, long data, and oh, we haven't actually talked about these classes yet. Oh, okay, so yeah, that's actually one that it should be just 1.1. Okay. All right, so I'm gonna let you guys do just 1.1 for a few minutes. Math class is also provided, and math class has a bunch of static methods. So, the math class is used for you to do computation, so it doesn't have to be per object basis. So that's the reason all these methods are provided in the form of static methods, like the getting an absolute value, getting a random value, getting max value, and getting minimum value between the two, getting a ceiling, getting the floor. So ceiling means return the smallest integer that is greater than or equal to the specified parameter a. And floor is the other side. And the exp, log, POW, I mean the bunch of all these methods, square root. So these are all available for you. So it's getting absolute value. So both of them should return 5. I'm getting a random value and then multiply by 10. I want to get the max value between these two, so 3.5. I want to get the minimum value between these two, it should return 1.2. And ceiling, so basically I want to get the next integer. Yeah, so ceiling is the whatever next value above this. Okay, so let me just yeah. So if you take a look at the ceiling is returns a degree value approximately equivalent to no, not that not that one. Ceiling, smallest integer. Okay, so smallest integer. So, basically smallest integer right above 3.5. So that should be 4. Okay. So this is long. Yeah. So these are all available for you. That's pretty much round, square root, and degrees, radians, and all that stuff. I'm going to move forward. Math class. This is, as long as you understand there are methods that does these things, that's good enough. Okay, so system class is probably more interesting. So let's talk about system class. So we have already used the system class, right? So we have used, in fact, the println. So system.out.println method. So we have used to display things. So system class provides many useful fields and methods. So it does, in fact, have 3 static input, fields. The in, out, and error. Okay, so standard input and standard output. And it does have a lot of utility methods for fast copying part of an array. So let's take a look at an example. So array copy. So, when you happen to have an array, instead of actually you doing the copying between 2 arrays, if you can use array copy, it's going to be a lot faster. Okay, because it's very much optimized. You can get the current time in milliseconds. You can actually call exit, so to terminate your program. Okay. Non-zero value means it's abnormal exit. Okay, zero value means it's the normal exit. Okay, GC means asking Java runtime to do garbage collection. It's a request. It's not mandatory. Okay, so JVM, when you receive this garbage collection request, it will take that and will consider for garbage collection. Okay. And set in, it basically, you can set the standard input device and standard output device by set in and set out. For now, the standard input device and standard output device is kind of set for you as a default. So, the screen is the standard output device and your keyboard is standard input device. And the screen is also standard error device. So when you see, in fact, system in, system out, that is basically representing the input and output devices of the application. Okay, so this is a case that we can get the current time in milliseconds, and we do some dummy things to spend some time, and we can get the time again, and we can actually see how much time it has passed. Okay. This is actually for doing array copy, so this is a lot more optimized. And this is for request for garbage collection. And this is for setting input device. So basically, I like to read things from this file rather than from console or keyboard. Okay, and this is Xing things out. We haven't talked about this input and output stream things yet, so we'll actually have a session on that later on. These are the system properties. So, you can find out the version of your Java, you can find out the vendor of the Java, JVM, and all kinds of information. Okay, so we're gonna actually take a look at this one later on. So, a lot of information. You can even find out the operating system name, operating system architecture, operating system version. It does even have a file separator. So in fact, when you're writing Java application, and if you have to deal with a directory structure, you can actually use the system properties in your program. Okay, so that it will be automatically select the correct file separator. So Mac OS and Linux, it will use /, and for Windows, it's going to use a /. Okay, same thing with the path separator. For Linux and the Mac OS, colon is used, while semicolon is used in Windows. Okay, line separator is the same thing. So if you want to write portable applications and that application deals with this path, directory path, and things like that, then you want to use the system properties instead of hard coding path like this. If you're hard coding like a /, that application might run on Windows platform, but it's not going to actually work on Mac OS and Linux. So in order to find all the properties, you say get properties method. You are going to call get properties method, and then you can actually print it out. Okay. We're going to actually talk about the properties class, and this is again built-in class that comes with the JDK. Okay. So it will display. So if you run this program, it will display, again the Java runtime name, vendor, and all kinds of information, Java runtime version and things like that. So we can actually do this as part of our hands-on lab. Okay, so that is exercise 2 and 3. So exercise 2 and 3. So system properties. So, we are going to run username test project. Username test project. Username test project. So let's run it. And username property Sang. Okay. So basically, it's going to it's going to call get property of username. If you call get properties, then it's going to give you all the properties. If you just call property and username, it will just return the name and it will display. Okay, so when you run this code, obviously it's going to display your name, not my name, right? And also you can take a look at the Java documentation. So yeah, I'm going to just go over here. So, if you go to system out here, and if you see the Java documentation, now, so you can see this Java documentation has 3 static fields, in, out, and error. Okay, so that's the reason you can actually use the system.in and out. Well, actually, when you see the code, you see this code, system out, because this is possible because is out is a static field. So in fact, this is probably the only example that the static field is being used in most Java programs. Okay, most of the fields are in fact private, but this is the only, I think, case that static fields are in fact the static public field. So we call this guy, and if you actually call, this out is basically a print stream method. So a print stream class. So print stream has a println method. Okay, so if you see, in fact, it has a lot of println method, and mostly we are using this guy, println stream. Okay, so that is that. And 2.2, we're going to actually display a system props project, and you can see it display lots of information. So here, we are just getting all the properties. So that is what display system props. This guy, and you can see, it does. Oops, not search result, output result. So you can see it display lots of information. So in my case, Java runtime, I'm actually using JDK 1.7.45, and the JVM version is this, and Oracle is a vendor, and let's see, I'm using Windows 7, and you can see there is file separator. What is it? Yeah, so here, file separator, because I'm using Windows, it shows the backslash. If you're using Windows, the Linux and macOS should actually have /. Okay, and Java home. Okay, this is a JRE location. Okay, and so Java class path and user home and all kinds of information. Okay, so that is the system properties. And you can actually set the system properties as well. So we're going to actually take a look at the set system properties. So you don't have to create a brand new project. You can just run set system properties. So let's just run set system properties. So this is the project, and run it. Okay, so in this case, what it does, I'm going to explain this one a bit. Okay, so when you run it, so I have a my properties.txt file which has my own custom properties. So here I have a subliminal message by Java now, and my own property, life is worth living with passion. So that is actually my text message. Okay, so in fact, if you go to, so let's actually whether we have that or we have that. So subliminal. Let's see, subliminal. Yeah, I'm gonna just search. So yeah, so this is the message by Java now, and also have my own property. Yes, so here. Okay, and then I'm gonna search my own. So if I search, yeah, here, my own property, life is worth living with passion. So basically, it's actually reading, it's reading. So if you take a look at the file structure, so click Files tab here, and set System Properties, you see there is a My Properties.txt file, text file. So this is the text file, okay? So in this code, what happens is that it's going to read this file and then merge with the existing the system properties. So that is the code. So let's take a look at the code. Okay, so let's take a look at the code. So we have file system input stream. Again, we haven't talked about the input stream and output stream yet, but for now you can think of file input stream is a class that reads a file. Okay, and then we have a properties class. Okay, so we are basically reading my properties.txt file through this file input stream. So we have property file in the form of file input stream object. And then we are going to create the properties object reading existing system properties. Okay, so we create a brand new properties file reading the system properties. Okay, and then we are going to load property file. So so basically we are just so this property file also read this property file. So we are basically merging system properties with the ones that I defined in my properties.txt file. Okay, and we can also set property method for the property. So my key one and my value one. So I should have that one as well. So if I go over here, my key one as well. So my key, yeah. So right here, my key value one. Okay, so I'm basically setting it inside the program, and then I just display those properties. So that is the code, and that is okay. So that is that. Yeah, so we did that. Yeah, so it's showing you all that stuff. And exercise 3 is a system class. So call methods of system class. So system class, so here, yeah, so we are basically calling current time millisecond. So if I run this guy, so system class, so let me run system class. Oh, so you have to select the project. Okay. System class and then run it. And time for manual copy is 5 milliseconds. Time for manual copy 1 millisecond. It's just kind of compare some of the tasks I've done. So if you take a look at the code, basically I get the current millisecond time, and then I do something, and then I get another current millisecond. I just kind of subtract it, and it just tells me how many milliseconds has passed for performing this operation. Okay, same deal with this. So you can see if you're doing array copy, so here I'm doing manual copy from array 1 to array 2. If I use the array copy, then it's going to be a lot faster. So it's taking only 1 millisecond instead of 5 milliseconds. Okay, so that is that. Get environment variables. So system, yeah. So if you want to actually find out the environment variables that are set, you can actually call get env, and you can actually receive it as a map file. So you can tell this it depends on the return type. So if you actually go to get env, so let's take a look at the system to. Let's run this guy first. Okay, so I got system environment variable. Okay, so if you take a look at the code, when I call get env, it returns a map types. So that's the reason you have to receive in the form of a map. Yeah, so we haven't talked about the collection. You can think of a map as one of the collection type. Okay, so if you take a look at the get env, the method Java documentation, it actually returns a map type. Okay, so this is a return type, right? Okay, so that's the reason you have to capture that as the map object. Okay, so that is that. And study println. So this is something I have already talked to you about. System, Java doc, and then you can actually see there are these static fields. And if I click println, you see this println statement. Okay. All right, guys, I'm going to give you about 15 minutes to try this exercise. Okay. Yeah, okay, 15 minutes. Next topic and final topic of this presentation is process and runtime classes. So process class provides methods for manipulating processes, killing processes, running processes, checking the status of the processes. Okay. And the runtime class represent runtime environment. So you can actually call the getRuntime method. You can see this is static method, right? And it returns a runtime object. And from runtime object, you can actually find out information about your runtime environment. You can actually run whatever application that you happen to have on your platform by using exec method on runtime class, okay? And returns a process object. So this is the, suppose if you want to run Notepad or in Windows, if you have the macOS, you might want to try TextMate. If you're using Linux, you might want to try, ls command or the gedit command and things like that. Whatever application you happen to have on your platform, if you run it within the Java application, basically you get the runtime object, and then you are going to call exec method of runtime object and passing the name of the command, and then it will run it. Wait for means I want to wait until that application exit out. Okay, all right, and if you misspelled it or something, it will just display unknown command. So we're gonna do just exercise 4. Okay, so let's take a look at exercise 4. So here we are going to run OS-specific program via exec method of the runtime class. So I'm gonna just run it. Here it's because on my Windows platform is just running the Notepad. Okay, so runtime exec. Okay, so I'm going to run it, and this Notepad is being displayed. Okay, so if you take a look at the code, that's the code that I've shown you. Okay. So again, it's actually waiting until the program is done. So if I run it again, okay, you can tell it's actually still waiting before calling wait for. Okay, so it's waiting until my program is done. So if I click this guy, then this returns, and then it will display after calling wait for method. So I'm gonna just close this guy, and then now you see the after calling wait for method is now being displayed. Okay, so depending on your okay, so it looks like we're actually checking it. So if it is a Windows, it's actually running Notepad, and if it is not Windows, it's gonna run gedit. I'm not sure Windows, so macOS has a gedit. If it's not, then just use a TextMate. Okay, so that is the runtime exec. For that one, okay, and memory related. So we like to actually see how much memory max memory and total memory and things like that. So that is runtime memory. So runtime memory, and run it. Okay, so maximum amount of memory that the Java virtual machine will attempt to use is this much byte. And the total amount of memory currently available for current and future objects and measures is this much. Okay, so so here we can actually get the max memory and total memory information. Runtime class 2. Okay, so you might as well just do this Java P command. Okay. Java P command is that comes with the Java. So if you go to, in my case, Java, and I'm actually using, you can go any JDK directory of your choice, and bin. Then you can see there is a Java P command. I'll just say Java. Okay, so there is Java P command. Okay, so Java P command, Java P help. If you say Java P command, it's going to dissect your class file and give you information. Okay, so let's actually try that. So we take a look at the Java P command, and you can actually find out the so if there is actually java.lang class. Okay, so I like to find out all the private method of java.lang string class. Then I can say Java P private and java.lang string. Okay, so it give me all the it looks like it's actually giving me everything even though I say private. Okay, let's see, show all classes and methods. Oh, looks like it shows all classes and methods. I don't know why it says private in that case. Yeah, if I say protected, let me see whether that works. Java P minus protected and java.lang and string. It's actually showing you. Oh, it doesn't show private. It's just showing you public. Okay, interesting. Okay. And so basically Java P. So let's try Java P on my hello class, right? So let's see. I go to my Java. Oh, looks like I don't. Oh, so hello Java. So I'm gonna just compile Java C hello Java. Okay, so now I have a hello Java, hello class, right? So I can say Java P and hello class. Then it will dissect hello class. It will dissect and actually give me the code. Okay, so if I say Java P all private and hello Java, oops, class. Why it doesn't actually give me compile from Java? Oh, should I just say hello? Oh, I kind of expected a bit more. Maybe, yeah, so maybe hello doesn't actually have anything, so that's why. Okay. All right, so anyway, so JXP is actually used to dissect your classes. Okay, so that's JXP. And build and run the application. So get runtime environment. Yeah, so this one, yeah, yeah, you can actually run the Java command like this, so this is probably not that much important. So I'm going to just skip this exercise. All right. So, all right. So I'm going to give you guys about 5 minutes to do this exercise, and then we're going to actually move forward with different topic.